Okay, practice question solutions. Starting with number 18. This diagram shows two flagpoles that are 4.5 meters tall. The distance from the top of the left pole to the base of the right pole is 7.5 meters. What's the distance between the two flagpoles? So we're looking for this distance here between the two flagpoles. We can call it D. We know that it'll make a right angle here because both flagpoles are the same height. And that's the side length we're looking to solve. We know the other two sides. This 7.5 is the hypotenuse, and the other two sides are the legs. So we can use our Pythagorean theorem equation. Doesn't matter which one's A or B. So we can just substitute in, let's say, D squared plus 4.5 squared equals C squared, which is the hypotenuse, or 7.5 squared. So we're looking to solve for D, so let's subtract the 4.5 squared first. That leaves us with D squared is equal to 7.5 squared minus 4.5 squared. And then let's take the square root of both sides. So D is now equal to the square root of 7.5 squared minus 4.5 squared. And when we simplify that, we end up with the square root of 36, and that is 6. So the distance D between the two flagpoles will be 6 meters. Number 19. Jerry drew a diagram to compute the distance he will travel if he drives from his home to the arena and then from the arena to the museum. What's the distance he will travel if he drives directly to the museum from his home? So you can see the distance here from home to the arena and then from the arena to the museum. But if he was to go a direct route from home to the museum, what would that distance be? Once again, we have a nice right triangle here. The two shorter legs are given to us, and we're looking for the longest side here, C, or the hypotenuse. So we can set up our Pythagorean theorem equation. 39 squared plus 52 squared equals C, or the hypotenuse squared. Square root both sides. C is equal to, we can plug that into our calculator because those are quite large values, and we end up with 65. Just make sure when you're putting this into your calculator that the calculator does the order of operations first correctly, does this piece inside brackets first so that it follows the correct order of operations. If you're not sure how to do that on your calculator, just let me know. Number 20. Allie walks along the path through the park. How far does Allie walk? Sorry for the mistake there. So we're looking for this distance here along the path. Once again, we know the two shorter legs of the right triangle. So 3 squared plus 1.5 squared will be equal to the length of the path. Let's say P squared. And we're looking to solve for P, so we square root both sides. And P is equal to the square root of 3 squared plus 1.5 squared, which when we calculate, that gives us 3.354 kilometers. It doesn't say how to round it, so we can just leave it as is. 21. A plumber is installing a pipe. The pipe needs to be offset to go around an obstacle. What's the length of the pipe needed for the offset? So this distance here is what we're looking to find. You can see that the pipe is going in this direction, but they needed to offset it so that it can continue out here, maybe so that it's dodging some sort of obstacle here. We know that the length and width or height of that offset is 24 by 24. We know that it's a right triangle. Those two sides are the legs. So we could go 24 squared plus 24 squared equals the offset. I'll just label that x squared, square root both sides, and x is equal to approximately 33.941 centimeters. Number 22, Benny thinks quadrilateral ABCD is a rectangle. Write the equation that could prove whether Benny is correct. So how do we determine if it's a rectangle? Well, if it's a rectangle, we would need to know that this angle here is a right angle. And we can verify that because if the Pythagorean theorem holds true for those three side lengths, then we know it's a right triangle. So let's check that out. The two shorter side lengths are 24 and 32. So 24 squared plus 32 squared must be equal to, if it's a right triangle, meaning a rectangle, 40 squared. And if we square 24, we get 576. And if we square 32, we get 1024. And if we square 400, we end up with 1600. And if we add these two guys together, we also end up with 1600. So there you go. We have verified that this is a right angle here, angle ABC, because the three side lengths, when used in the Pythagorean theorem, hold true. Number 23, the logo is made up of four congruent right triangles. Find the perimeter of the logo. So perimeter would be the distance along the outside. So kind of a line here following the red line. And we know that this distance between here and here is just 1 unit. So we have 1 unit, 1 unit, 1 unit, 1 unit. But the section that we have to find is this section here. So if we know that this side length is 3, and this side length here is 4, and they meet at a right angle, then we can use the Pythagorean theorem to find this side length here. So 3 squared plus 4 squared equals x squared, square root both sides. X must be equal to the square root of 3 squared, which is 9, 4 squared, which is 16, and x is equal to the square root of 25. And one step further, the square root of 25 is 5. So if we know that each of these side lengths are 5, then the perimeter would be 4 of those side lengths, 4 times 5, plus 4 of those 1 unit side lengths. Totaling that up, we would get 24 units.